You are exhausted. Your body aches for rest, your mind is fatigued from a day of high-stakes decision-making, and you finally lie down to sleep. But instead of drifting off, you find yourself staring at the ceiling, wired and awake. If this sounds familiar, you aren't failing at sleep. Your biology is simply responding to the environment you've built around it. Right now, that device in your hand, or the screen you just turned off, is running a silent, invisible script. It is tricking your brain's most ancient timekeeping system into believing it is solar noon. Welcome to My Sleep Renewed. Today, we are exploring the neuroscience of screen-induced insomnia, and more importantly, how you can use a specific spectrum of light to biohack your pineal gland, signal safety to your nervous system, and reclaim your biological drive to sleep. To understand why we struggle to shut down, we have to understand how our eyes actually work. Your eyes are not just cameras taking pictures of the world, they are highly calibrated biological clocks. Deep within your retina lies a specialized group of cells discovered relatively recently in the timeline of neuroscience. They are called intrinsically photosensitive retinal ganglion cells, or iPRGCs. These cells don't help you see shapes or colors. Their sole evolutionary purpose is to measure the brightness and wavelength of light in your environment, specifically the sharp, short-wavelength blue light abundant in midday sun. When you stare at a phone, a tablet, or a TV at 10 p.m., these iPRGCs detect that concentrated blue light. They immediately send an electrical panic signal to the master clock in your brain. Neuroscience indicates that this artificial light acts as a neurochemical emergency brake on your sleep drive. It tells your autonomic nervous system that the day is still at its peak. In response, your body keeps your core temperature elevated and your cortisol, your primary alertness and stress hormone, pumping through your veins. You are asking your body to rest, but you are visually signaling it to prepare for a midday sprint. This brings us to the crucial checkpoint of high-performance recovery, the pineal gland. Located deep within the brain, the pineal gland is the manufacturing center for melatonin. But here is a critical misconception: melatonin is not a sleep-generating hormone. It is the hormone of darkness. It acts as the biological starter pistol that tells the rest of your brain and body that the race of the day is over, and the phase of repair can begin. But the pineal gland operates on strict conditions. It will only release a robust surge of melatonin if the iPRGCs in your eyes report that the sun has gone down. When we flood our evenings with artificial blue light, the pineal gland's production is suppressed. Without that hormonal starter pistol, the nervous system remains in a state of vigilant activation. The body keeps the score of this chronic, low-grade stress. Over time, this delayed recovery drastically impacts cognitive sharpness, emotional regulation, and physical repair. To optimize performance, we don't just need to close our eyes. We need to recreate the sunset. So, how do we hack this evolutionary mechanism? We use the physics of light to our advantage. Unlike the short, aggressive waves of blue light, amber and red light sit at the opposite end of the visual spectrum. They possess long, slow wavelengths. From an evolutionary standpoint, the only time our ancestors saw warm, amber light was from the setting sun or the glow of an evening fire. Because of this, red and amber light do not trigger the iPRGC alarm system. Studies suggest that when you shift your visual environment to red and amber light, it signals profound environmental safety to your nervous system. This specific spectrum allows your cortisol levels to naturally plummet. It gives your autonomic nervous system permission to stand down, and it gives your pineal gland the green light to flood your system with the melatonin required for deep, architectural sleep. This isn't just about avoiding screens, it's an active, engineered protocol for high-performance recovery. Here is a practical, science-backed protocol many high-performers use to implement the red light hack tonight. Step 1. The 90-minute dim down. Set an alarm for 90 minutes before your target sleep time. This is your biological twilight. Turn off all overhead, fluorescent lights in your home. Step 2. Environmental modification. Transition to low-level, amber or red light sources. You can use specialized red light bulbs in your bedside lamps, or simply utilize high-quality blue light blocking glasses with red or amber lenses if you cannot control your environment. Step 3. Screen mitigation. If you must look at a screen, utilize the built-in color tint features on your devices. Go into your accessibility settings and turn your screen purely red. It removes the aesthetic appeal of scrolling, while entirely blocking the melatonin-suppressing blue wavelengths. Step 4. Respiratory synchronization. While bathed in red light, combine this visual cue with a physiological one. Engage in 5 minutes of slow, deliberate nasal breathing, inhaling quietly through the nose, and extending your exhale. This mechanical action pairs with the red light to forcibly down-regulate your nervous system, pulling you out of fight or flight and into a state of deep rest. Your environment dictates your biology. By controlling the light you consume in the evening, you stop fighting your neurochemistry and start working with it. You transition from wired and tired to focused, recovered, and renewed. If you found value in this protocol and want to dive deeper into the neuroscience of performance and recovery, make sure to subscribe to My Sleep Renewed. Prioritize your rest. Optimize your environment. We will see you in the next video.